I'm going to be graphing y is equal to 3/2 sine times the quantity x over 4 minus 3 pi over 4. A couple of things I want to find before I go to do my graphing, and the first thing is the amplitude, and the amplitude is the coefficient of the function. In this case it's 3/2, and we want to make sure that we take the absolute value of 3/2, which still gives us 3/2. So my amplitude is 3/2. That means that from my 0 point to the maximum is 1.5, and then from my 0 point to the minimum is also 1.5. The next thing I'm going to look for is see if I have a vertical shift. So if I'm adding anything outside of the parentheses, outside of the function here, I have a vertical shift, and I'm not. So vertical shift, there is none. Next I'm going to be looking at the period, and the period is equal to t, and that's 2 pi divided by omega. And remember that omega, for this particular problem, is the coefficient of your x term. So we have to look over here at our x term and look at what the coefficient is. And remember, there's a 1 in front of that x there. So my omega is equal to 1/4. Using that, my period then should be 2 pi divided by 1/4, which is equal to 8 pi. So my period is going to be 8 pi, and I'm going to double check that when I figure out my phase shift. To do my phase shift, I'm going to take my original argument that I have inside of my function here, and I'm going to put it between 2 pi and 0. So I have 0, and this is the normal period for my sine function. And this is going to give me a phase shift, and it's also going to double check my period of 8 pi. So first of all, I'm going to add 3 pi over 4 to all sides of the inequality. When I do that, I end up with 3 pi over 4 is less than or equal to x over 4, which is less than or equal to, and then 2 pi is actually 8 pi over 4 plus 3 pi over 4. So then my phase shift becomes 3 pi over 4 is less than or equal to pi over 4, which is less than or equal to, I'm sorry, not pi over 4, which is less than or equal to 11 pi over 4. Now I need to get the x by itself. I'm going to multiply by the reciprocal, which is 4 over 1. So every term is going to be multiplied by 4 over 1. And my inequality becomes 3 pi is less than or equal to x, which is less than or equal to 11 pi. So this tells me two things. First of all, it tells me that my phase shift is this number right here. So my phase shift is equal to 3 pi. That means in the positive direction I'm going to be moving to the right, 3 pi. And it also tells me what my period is. So my period is the difference between my minimum and my maximum on the x-axis. So 11 pi minus 3 pi gives me 8 pi, and this checks with the period that I had over here. So the periods check, and I know that I've done everything correct. Now I'm going to go ahead and graph, and I'm going to make sure that I have enough hash marks to be able to graph this correctly, and then I also have an amplitude of 3.5, so I want to be able to graph that. So I have a graph here now, and you've noticed that I have changed my increments, and I've made every 2 lines worth pi, and I go from pi to 11 pi in the x direction. I only have to worry about the positive. And in the y directions, I'm going from 0 to 2 in the positive direction, and then in the negative direction, I'm going from 0 to -2. I'm going to go ahead and graph this now, and I'm going to be starting, since we're talking about sine, our general appearance of this is going to look like a worm, and the worm looks something like this. So that means I start at a 0, I end at a 0, and I have a 0 in the middle of my cycle. So at the beginning of my cycle, I'm going to be at 0. That means, and notice that I've divided my period into 4 sections. So between 3 pi and 11 pi, there's 8 sections. And so every 2 pi, I've divided it. You can see the green line there. I'm going to start at 3 pi. That's going to be at 0. I'm going to end at 11 pi. That's going to be 0. So that's the beginning and the end of my period, and then in the middle, so I have to find the middle, which is 7 pi, I'm going to also be at 0. Then I have to figure out my maximum, and my maximum is going to be found by the amplitude. And my amplitude is 3/2, which is the same as 1 and 1/2. So from 0, my x-axis, at my first quarter, I'm going to be going up 1.5. So there's my amplitude in the positive y direction. And then I go past 0, and I'm going to go to my minimum in my third quarter, and that's going to be down 1.5. So now I have my 5 points, my beginning, my end, my middle, and my 2 quarter points, and I can go ahead and graph the function. And remember, it's supposed to be nice curving lines. The next function I'm going to do is y is equal to -2 cosine of negative x minus pi over 3 plus 3. Before I can do anything, I need to make sure that my coefficient of my x, or my omega, is positive. It always has to be positive. So the first thing I'm going to do is I'm going to factor out a negative from inside of the parentheses here. When I do that, I end up with y is equal to -2 cosine, and I'm going to put this in a square bracket, negative x plus pi over 3. Now I'm going to use my even-odd functions, which tell me that if I have the cosine of a negative theta, that is the same as the cosine of a positive theta. So this negative that I have here, I'm going to need to get rid of it. And when I get rid of it, so this negative here, this is the negative, these two are the same. Theta is what I have in parentheses here. And it says if I just remove that negative, it becomes a positive function. So that's what I'm going to do. I'm just going to remove the negative and rewrite it. So I'm going to remove the negative and rewrite it without the negative here, and it's still the same function. So I have y equals -2 cosine x plus pi over 3 plus 3. And it's the same function. The only thing I've done is I've taken the negative and said, hey, my even-odd function tells me that if I have the cosine of a negative, it's the same as the cosine of the same thing in positive. The next thing I'm going to do is look at my amplitude. And my amplitude is the absolute value of the coefficient of your function, so it's the absolute value of -2, which is 2. My vertical shift is what I'm adding outside the function here, so that's my 3. So it's going to be 3 up. Then I'm going to look at my period, and my period is going to be 2 pi over omega. And remember, omega is the coefficient of my x, so omega in this case is equal to 1. So my period then is going to be 2 pi. And then my phase shift, I take what's inside the parentheses, and I'm going to put it between 0 and 2 pi. So I subtract pi over 3 from everything, and I end up with negative pi over 3 is less than or equal to x, which is less than or equal to, and 2 pi becomes 6 pi over 3 minus pi over 3, which gives me 5 pi over 3. If you want to check your period, you can do that. Just take 5 pi over 3, subtracting negative pi over 3, and that should give you 6 pi over 3, which is 2 pi. So it checks. My period checks. Remember, this is my phase shift, so that means I'm going to be moving to the left, pi over 3. This is my starting point. This is my ending point. So now I'm going to go ahead and graph, and I have to make sure that I take into consideration that I have a vertical shift of 3 and that I have an amplitude of 2. So that means I'm going to have to be going up 5 at some point. So I have my graph set up here. I'm going from negative pi over 3 to positive 5 pi over 3. And when I just do those in brown, you can see that I have 1, 2, 3, 4, 5, 6 hash marks. And that's a problem when I want to divide my graph into fourths. So I want to have hash marks in between, and when I put the hash marks in between, it's going to be half of pi over 3, which gives me pi over 6. So this is negative pi over 6, and this is positive pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5, 6 pi over 6, and then 7 pi over 6 is my divisions. So I needed to do that so that I could divide my graph equally into 4 parts. Now I'm going to go ahead and graph cosine, and remember that cosine looks like a bird. Draw it over here on this side here. So it looks like a bird. So that means that I would normally start off at a maximum and end at a maximum. But I have a negative coefficient. So that means we have a reflection going on, and it's going to be the opposite. And you've heard me call this in class the flapper look. So now we have a flapper going on. So that means we're going to start at a minimum and end at a minimum. So I'm going to go ahead and start graphing. I'm going to first of all put in my vertical shift, which is up 3. So I want to have that in here because that's going to make my graph a little bit different when we have those vertical shifts. So from my vertical shift at negative pi over 3, I'm going to be going up and down 2. Well, to start with, I'm going to start at my minimum. So from my vertical shift, I'm going to go down 2. And that's where I'm going to start my graph. Where I'm going to end my graph is also at that same minimum, negative or down 2. So I'm actually graphing at negative pi over 3, 1. Then my middle term, or I'm sorry, my middle division, I'm going to be at a maximum. So from my vertical shift, I'm going to go up 2, 2. And then at my quarter points, I'm going to be at 0, or at the 0 line. In this case, the 0 line is my vertical shift. So at my quarter point, which is pi over 6, I'm going to be at 0. And at 7 pi over 6, I'm going to be at my 0, which is actually my vertical shift. When we're having problems like this, if you don't have your graph clearly labeled, you may want to put in that this is pi over 6, 3. So actually write the points down. And then this is the point 7 pi over 6, 3. And then our maximum, you might want to also write that down. It's 2 pi over 3, 5. And your minimum, in this case over here, is negative pi over 3, 1. And your maximum is 5 pi over 3, 1. Then I'm going to connect all my dots. I'm going to have a nice curve going on here. And now I have graphed one cycle of my cosine graph for this particular problem.